I hope I'm streaming. I'll wait until it shows here and close it before we get any annoying feedback. So as always, hi everybody. I'm Moshe Zadka. Hopefully you figured it out already if you're watching the stream. And this is a stream about solving programming challenges in Python. And today we'll be talking about this question, because nobody, by the way, if any of you watching the stream and have an interesting programming challenge, maybe something you got at an interview or something that you thought was kind of fun, please let me know. I'm super happy to work on other challenges, but unless someone tells me, I'm gonna choose my own. So today, I saw this coming in from like one of the approximately 5 million mailing lists I'm subscribe to, which send you coding challenges in various frequencies. We're like, that's interesting. Let's kind of talk a little bit about that. So we'll be talking today about Huffman coding because it's kind of fun and cool. So what is it, right? So let's read the description. Huffman coding is a method of encoding characters based on their frequency, blah blah, descending to a left. And I guess here they don't specify the only interesting thing, a property of a Huffman tree, right? Because like theoretically, why should they care about the character frequencies, right? Like here giving a dictionary of character frequencies. So this question is not written that well. The real answer is that we want, of course, to minimize average length. Right, so meaning that like given a dictionary of character frequencies, we want to make sure, right? So let's say that frequencies, and let's only have like 4 letters because, dear God, I don't have time for more than that. So let's say that you'll see about. Right, I have no idea if that makes sense, but you know, let's say that this is the frequencies you got. What we want to make sure is to minimize sum of, you know, length of x times frequencies of x for x in, right? Obviously we don't have that, right? Because we don't have the coding, but we want to make a Huffman tree that will minimize this, right? Otherwise, why should the character frequencies matter? As you can see, this doesn't talk at all about the frequencies. Okay, so let's do that. And part of the reason that I thought it was a fun thing is because I recently wrote an article for Real Python about the heap queue module. And there's all kinds of problems that heaps can solve. And I kind of talked a little bit about in the article. So if you want to see that, I'll put the URL in the show notes when I upload it to YouTube. Or you can literally just Google Real Python heap queue Moshe and you'll probably find that. Anyway, so I will, what did I want to say? Okay, yeah, so, and in the article, I talk a little bit about how to recognize things that look like they would be a good example for heaps. And you notice I said the word minimize here. And as soon as you hear the word minimize, you should always think, should I use a heap, right? Like, and a heap is only part of the solution, right? Clearly, you can just use a heap and magic it up. But so let's start with that. Okay, so what I want to do. So I want to and we'll build a Huffman tree for frequencies, right? So the first thing we'll do is like we'll define kind of like a weird data structure. So let's import utter, because that's always a fun thing to define data structure. And I want to say we want to have a data structure of a node in the tree, right? And you notice that a node can be either a letter or an intermediate node. So let's kind of do that, right? Let's say that we have, and I always like to make things immutable. Immutability is cool. And so we basically need two classes, right? Like one class is like leaf, and then you can just say character. And that's gonna be an str. It really should be like, one character str, but like I'm not gonna bother too much about specifying that, right? Basically definitely not for this thing. And then I want to say, and no, I actually want another thing. Yeah. So we'll also, again, like kind of using really heavy things, we'll use the interface from ZOP import interface. And I want to define an interface, and the interface is gonna be class say has frequency, and has frequency basically just has frequency. So frequency equals, oh god, I haven't done that in a while, so let's remember. I think it's called attribute, but I wanna see what it's called. Yeah, attribute, right? So frequency equals interface attribute, and let's see what can we give to attribute. For now, we'll just say frequency, and here leaf will just have frequency float, and we want to say that it implements it. So under interface implementer has frequency. Did I not? Oh, I didn't. Okay, cool. Right, so that's right. So it has a frequency, which is a float. Okay, and we can just remove that. That's not interesting right now. And now, and the reason we wanted this has frequency class interface, sorry, is that, let's say auto attributes equals true, frozen equals true. We'll call it node, and we want to say left. So it's an optional because we want to say that it's not right. You notice that things can have only right or only left, and occasionally you have to, so we'll do that. That's fine. It means some things just don't code to anything, and occasionally that's the best you can do. This is why, in real encodings you actually use wrappers around Huffman encoding. But you notice that this has to have a frequency as well, right? Because it also implements as frequency. So it has to have a frequency and a frequency float, right? And now, whoop. Yes, of course, I need to import optional from typing import optional. Okay, cool. Yeah, so now we have that. And basically what we want to do is we want to say this. That should be frequency. Okay, and now I want to say this. Oh, and I want to have this def from nodes. That should be a class method. That's going to come in handy later. Class left, right. And what I want to do is do this. So you here, so let's kind of like, this is optional. Here's frequency. This is optional. Here's frequency, and it returns a node. And oh, I probably want so that it'll actually work. Otherwise, this kind of circular reference doesn't work. Okay, so now we do left, right equals right. And I want to know what frequency to give, right? So frequency is left. Let's define a little bit. Def get frac thing. If thing is none, return 0. Otherwise, return thing dot frequency. And now we can just say sum map get frac left right. Okay, so that's the frequency of a node. Wait, so let's why do I define the frequency like that, right? If you think about it, what is the frequency that you'll get here? Well, if you get to A or C, then you'll go through this node, right? So the frequency that you'll kind of get, right? So if you think about like what is the frequency of a prefix in Huffman, the frequency of a prefix, right? 0, 0, 1. Okay, I guess maybe if we think about the frequency of 0, the frequency of 0 is the frequency of everything under 0, right? The frequency of 1 is the frequency of everything under 1. So, by the way, there's never actually a reason to do that. You could just fold S to that. So I don't think I actually need optional. Let's kill all this optional. All this optional is making me annoyed, and I don't think I'll need it. Let's kill it. And if we need it, we'll give it later. This makes our code much simpler. Okay. I don't have to put options here. Not here. And I don't even need this. I can just literally just do math, right? I can just do left dot frequency plus y dot frequency. Okay, cool. So yeah, so this is the frequency of a node. Okay, so we can automatically calculate, and then frequency equals frequency. Okay, cool. So actually now the code is really easy. What we do is we do this. My heap def get Huffman of frequencies. And this is what we do. We do my heap equals. So I guess first we will convert it to leaves. Okay, so leaf of I can just do this directly. My heap equals this for character frequency in frequencies. Yep. And let's call it my heap. And the next thing we want to do EPify. Wonder how I can get help here. Well, if I can do another way, I can just do this help heap q. This is probably some Jupyter. Transform a list into heap in place. So my heap. And let's print my heap and return none for now. And let's do get frequencies dot items. Yes, this is why it's good to kind of like, okay, so this just converted to the leaves, right? And that's good because that's the leaves we're gonna need. And now we do this while len my heap is probably a slightly faster way to do it, but well, let's kind of, so as you can see, the heap is what the people would call a min heap, right? It first has the smaller things and then the bigger things, right? So this is going to be important, right? So let's do kind of heap q dot heap pop. We'll call it left. So we will notice that this has to succeed, right? Because let's kind of do bigger than 1. This is defensive coding, because bigger than 1 is at least 2. So I can pop at least twice. Maybe I've popped everything, but I can pop at least twice. Now we have 2 nodes. What are we gonna do? Well, like, you know, this is like a Chekhov's gun, right? We're gonna call node dot from nodes left right. Let's call it new node. And now you notice that this new node has a frequency, right? Because it has a frequency. So I'll do this. New node equals new node dot frequency. And what do I want to do? I want to do new node equal dot frequency. All right, heap q dot heap push. And I really don't remember. Let's do help heap q dot heap push. I think it's probably first the heap, right? So the heap is my heap, so that's easy. My heap, and you notice that we always oh right, we should do this. Ignored. And this is very typical. You want to ignore the sort key. In some sense, right, the sort key is anyway redundant, right? Because like whatever is here already has a frequency. All the sort key does is make sure that the heap is sorted correctly. And we could probably have overloaded less than exactly the right way, but that's kind of annoying. So I'm not going to bother. My heap new node dot frequency new node, and that's it. Right, so you notice that each time we remove 2 and we add 1, so on net we remove 1, right? The length is gonna be 1 lower, so you know eventually this has to terminate. And we can print, and this is one of the cool things about Auto, right? We can literally, so when we're done, right, by definition we only have 1, because otherwise like this would fail. So let's call it tip. Destructure it. Tip equals my heap. Let's print the tip. And still return none because I just want to see that I'm building the Huffman tree. Right, at this point we're building the tree, right? Not the encoding, but the tree, right? But that's a good, because that's a good first step, right? We're building the tree. Might actually want to refactor it later, when we will kind of do that later. But get Huffman frequencies, right? So oh, and right, we actually want structure it a bit more. Yeah, right, we want to have the node, right? And this is maybe like an annoying way to print a tree, but it does print. So let's str false. Yeah, so let's implement our own str. And it'll kind of be a hack, but that's fine. We can make a few hacks in str. Under to str with indent. No, that's not what I want. That's not what I want. I want this. I know what I want. I want to use another trick in others. as a dict, yeah. So if we do import pprint, oh, we should just return the tip here. Instead of printing it, return tip. Let's call it get Huffman tree. And then we actually are done with that function. Oops. Yeah, that's better. Yep. I need a function from it. Okay, so this is kind of nice, right? This kind of prints nicely, right? So we have on the left, right? Like, so you remember that our frequencies, example frequencies, A was really, really big, right? So because A is so big, we kind of put it at a kind of like one side, so it will eventually encode it by 1 bit. And then S will be encoded by 2 bits. And C and T will each be encoded by 3 bits. Right, so that's a tree. Right, and now that's pretty cool. Now let's do something to kind of def get encoding from tree, and then we'll do it should be called get Huffman tree now. Right, and now we'll do def get encoded from tree. And we do this. We define an inner function called get encoding from tree with prefix. Let's have a prefix and a tree. If let's do this. Okay. Again, keeping with, like, you know, let's use kind of pretty fancy things. Okay, then in that case we want tree first and prefix second. And all we know about the tree is that it has frequency, right? It's part of the has frequency. And so this is like, and prefix will be str, and that's going to be single dispatch, and the default will be raise not implemented error cannot convert tree. Okay, so that's clearly not a useful function, but now we do at get encoding from tree with prefix dot register for a leaf. That's very simple. Def for leaf. Again, it has to have the same parameter, but now I can assume this is going to be a leaf and prefix is still going to be str. And if I got to a leaf, all I have is the prefix, right? So I just yield prefix and tree dot character. And for node, loop loop for node, and mapping. I don't like the word between. Do you want the mapping from characters to encodes or vice versa? We'll assume that they want the mapping from characters to encodes. And you can always reverse it later. Okay, so for no. Tree is prefix, side, and prefix plus str of bit. Right, so bit is going to be either 0 or 1 because we're counting 0, 1. So get yield from encode, right? So this will just return all the things, and they all start with a prefix, right? You remember that this just returns a prefix, this adds, so by definition everything has to. And now that we have defined it, we can just do return. Right, we decided we want character encoding. In get encoding from tree with prefix, and of course the initial tree will be our tree, and the initial prefix will be the empty string. And I already have the close, so that should be it. Okay, so now oops, when I copy paste. Okay, so that looks better, and let's just kind of put it right here. So we already have the tree, so let's do get encoding from tree of tree. Character encoding. What is the name error? Node is not defined. Because it should be tree. And as you can see, A is encoded with 0, S is encoding with 10, C 110, T 111, and that's a good Huffman encoding. And now to define get Huffman encoding, we just do get Huffman encoding of tree of frequencies. We just combine it, right? We just do get encoding from tree of get Huffman tree of frequencies and there we have it. Ooh, this took longer than I thought it would, but hopefully everybody had fun. We can just remove that. And let's kind of go over like the code we have, right? Even though I kind of said I'm gonna stream for 30 minutes. Let's kind of like remove all the stuff we don't need. It's kind of, I kind of like when I finalize like to kind of collapse all the imports into one import, right? Because like when you explain stuff, right, like SV, right, and then we have to kind of do copy paste here. We could like do something fancier, but it's actually faster. This, and now let's kill these cells. And I think we probably also have an import. Func tool somewhere, and we really should do that. Okay, let's fix that. Bloop. And we can kill that. And here's a cool trick. We can print frequencies. And now we can paste it back. So this is kind of something I like to do when I'm done with a notebook, or kind of when I prepare a notebook for presentation, right? You folks have seen like the kind of the making of, right? Like, so you saw that, like, it's kind of messy as it gets made. But when you're done and you want to present it, right, and you kind of clean it up, and then to make sure that it all works, right, I kind of restart the kernel, so now I don't have any variables in memory. And it kind of looks all nice and easy, right? Like we didn't have to think, we didn't have to worry, right? Like we just knew what we were doing, and we're done. So yeah, heaps are pretty cool. I guess check out my article on realpython.com. Right, you saw that basically all I needed to do was wrap a heap, and that was pretty much it. Like 90% of the code here is just like literally like this line, this line, this line, and this line are just using the heap module. So 4 lines out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Basically 40% of the code is just calling heaps. And like if you kind of ignore, basically like the return and the unpacking at the end to kind of clean it up, basically it's just mostly using a heap, right? The core loop is literally just using a heap. So one trick was just to have kind of a leaf and a node classes that all have frequency, so that the core loop just has to call node from nodes. Oops. The core loop just has to call node from nodes, and node knows how to treat as frequencies, right? Left frequency plus right frequency, right? Because like I said, like the right, if you kind of look at the Huffman tree here, then you see that the frequency of the, right, we do import pprint dot utter as dict to kind of get like a nice printout here. Right, then you will see that the frequency of the tip is the total frequency, which is not interesting. But the frequency of A is 10, and the frequency of what's in the right side is 12, because it's a sum of 5 and 7. Right, and the frequency of the right side here is 7 because it's 3 and 4, right? So it's the tip of each tree, right? It's like the at every node, right? It has a frequency which is the sum of what's underneath it, because that's how we define it literally, right? So we had kind of like a nice implementation of a tree structure that remembers at every point what is kind of the total weight of the whole subtree below it. And then once we had it, we just said, okay, let's start with like a bunch of a forest, if you will, of like size 1, and let's just each time get the two smallest trees and wrap them into one, two smallest trees and wrap them into one, two smallest trees and wrap them into one, until we get like, you know, one tip. Then the tip is gonna be like everything else, right? Because each point we unify two things into one, so the tip is gonna be everything else, as we saw earlier. And now all we need to do is just read the encoding from the tree, right? So reading the encoding from the tree is easy, right? We just say, okay, if you want to get to C, that's 0, 0, 0. If you want to get to A, that's 0, 0, 0, 1. Right, sorry, no, it's 0, 1. If you want to get to 2, it's 1, 0. S is 1, 1, 1. Right, and now if we want to encode cats, let's say like we want to kind of encode, right? So code. Let's see, text. Then we do and with encoding. So encoding. I'm not going to put the type here because we are running out of time. We do dot join. Encoding of x for x in text. We get a different and yes, encoding, of course. We'll get a different result from the result there because we actually used a different frequency table. Here we go. But you see, C is right. So C is 110. So 110. Then A is 0. Then 111. And then 10 for S. Okay, so we encoded cats. Technically, that was not part of the problem. The problem was just yeah, nope, yeah, yeah, I just wanted to kind of keep this line here. It was a bit aggressive. Here we go. Okay, so like I said, I really like having my things clean, and now we can literally just restart the kernel and make sure that everything looks good. Nope. And we got the right encoding. We can remove the empty cells and get like a nice thing. Anyway, I don't know if you know that, then you can export notebook as HTML. Can I just, yeah. And then like have kind of a nice HTML output. Let's create the font for you folks reading the stream. So you can then kind of like, publish that HTML somewhere if you kind of have a web page. And, like if you really enjoy doing this kind of stuff that you kind of publish, you can decorate things. And I don't know if you have seen that. But I wrote a post, A Labyrinth of Lies, on my blog, if you want to check out my blog. And basically that's exactly what I did, right? I took a Jupyter-led notebook, I did an export, but before I did the export, I kind of added some documentation, and I got a really nice blog. So this is kind of like a path to kind of getting like a really nice publishable thing that you can try. Obviously that's not really nice, but if I actually clean it up, but that's part of the cleanup, right? You want to make things look nice, but we're already 15 minutes over, so I hope everybody had fun, and I'll see you next week. Bye, everybody.